All right, here we have questions 4, 5, and 6, which are all non-calculator questions. Number 4 is going to be integration by partial fractions. So we have to factor out that denominator, and it actually factors into 3 different factors. When I first factor out an x, I'm left with x squared minus 1 times x, and then of course I have difference of squares, which I factor into x minus 1 and x plus 1. So I can rewrite my fraction as a over x plus b over x minus 1 plus c over x plus 1. And then when I find a common denominator and just focus in on the numerator, I'm left with the equation 1 equals a times x minus 1 x plus 1 plus bx times x plus 1 plus cx times x minus 1. And when you have 3 terms on the right from 3 fractions that you decomposed into, all you have to do is use then 3 different x values. Make sure you negate each term. So x minus 1, you use x equals 1. X plus 1, you use negative 1. And then plain old x, you use 0. So if I plug in x equals 1, I negate the a term, or I don't negate it, I zero it out. I zero out the a term and the c term. So I'm left with just the b term. And I have 2b equals 1, so b is 1/2. Do the same with x equals negative 1. And I end up with the a term gone and the b term gone. And for my c term, I have 2c equals 1, so c also equals 1/2. Then the x equals 0 term, my b and c terms are zeroed out, so I'm left with just the a term, which will give me negative a equals 1 and a equals negative 1. So just make sure you're associating a, b, and c with the proper fractions. So my a negative 1 goes with a over x. So I factor out the negative 1 in front of the integral. I have the negative integral of 1 over x, and then I place my b and c values of 1/2 out in front of the integral as well. And then I integrate each of these with natural logs, so negative ln of absolute value of x plus 1/2 ln of x minus 1 plus 1/2, that should say ln right there, sorry about that, 1/2 ln of x plus 1, all with the absolute values, plus c. Now you could work if you wanted to combine these, and I'm just going to show you a couple of different things you could do. Whoops, as I do it wrong. You could multiply the x minus 1 times the x plus 1 after you factor out the 1/2. So you're going to have ln of the absolute value of x minus 1 times x plus 1 plus c. Then you could bring up the exponent. So you'd have the negative ln of absolute value of x plus the ln of the square root of x minus 1 times x plus 1. And then certainly you could then do a division where you're dividing this guy by this guy since the negative's in front of here. So you have the ln of, and I'm going to put it all in the absolute value, square root of x minus 1, x plus 1, all over x. That might be the way that they give you the answer if you're doing multiple choice. For your purposes of your gateway, you can certainly leave it as I left it in the key, which is that. Okay, part 5, question 5. I'm going to use all this white space over here because I didn't work it out in the key, but I want to. This is a cyclical problem. So we need to use integration by parts twice, and we have to then set it equal to the original. So let's do u equals e to the x, and dv equals cosine x, du equals e to the x dx, and v equals sine x dx. So now I want uv, which will be e to the x sine x, minus the integral of v du. And just keep in mind when you're doing your second iteration of integration by parts, which is from here, make sure you call u e to the x again. Don't change it, otherwise the cycle will not work. So du is once again e to the x dx, and v in this case is going to be negative cosine of x. So then I need to bring down this term e to the x sine x, and then I need to negate all of what I'm about to do. So I put a big bracket around. So I have uv, which is e to the x times negative cosine x, so negative e to the x cosine x, minus v du. So I'm subtracting a negative here. So I'll make it positive, e to the x cosine x dx. Now I'm going to go ahead and combine all these. So I'll have e to the x sine x plus e to the x cosine x plus the integral, minus the integral of e to the x cosine x dx. And remember that that is going to be equal to your original, which is the integral of e to the x cosine x dx. So when I add this term to both sides, I end up with e to the x sine x plus e to the x cosine x equals twice my original. So to get my final answer, I need to divide this by 2 and of course add a plus c, and that will be my final answer. For part 6, I think I have all the work on here, so I won't need another page, but I have to do long division because I have a bigger degree in my numerator than I have in my denominator. So remember, when you do your long division, you have to put a placeholder in for the missing x term. So under the division symbol, I have x squared plus 0x plus 2. So I have x going into x squared, x times x is x squared, x times 2 is 2x. Remember, I am then subtracting out here. So 0x minus 2x is negative 2x. Bringing down that positive 2 to here, x goes into negative 2x, negative 2 times. Then I can multiply to get negative 2x minus 4, and remember, I am subtracting this out. So negative 2x minus a negative 2x is 0x. 2 minus a negative 4 is 6. So that means I can effectively rewrite this fraction as the integral of x minus 2, which comes from right here, plus 6, which is the remainder, divided by x plus 2. X integrates to x squared over 2, negative 2 integrates to negative 2x, and then 6 over x plus 2 integrates to 6 times the natural log of the absolute value of x plus 2, and add your plus c, and you're done.